Agronomy Division at IIMR, and was conducting several taking place the several external funding projects also, including the drone project. So now I invite our today's resource person, Dr. B. Gangaiah, sir, to deliver a session on this particular aspect, sir. Sir, once again, welcome, and over to you, sir.
Thank you, Sangappa, for nice introduction and taking pains to gather these many people. So I welcome all the participants from KVK and also ECRIP system and ICR SAUs for this webinar. So in this probably 1 hour lecture, we try to, I am audible to you? Hello?
Yes, sir. Yes, sir, you are audible, sir.
In
I think
1 hour or so, we are going to look how these millets farming is changing, contributing to food security, and how they needs to be continue their role under changing climate. You know that first, before going into the actual climate change and all the nitty-gritties, we would like to introduce the millets. Millets are nothing but they are very small seeded cereal crops. If you look at the maize crop, the 1000 seed weight is 250 grams. And the 1000 seed weight of millets is 40 to 80 times lesser than that of maize. You think the sorghum its seed weight is as much as a rice crop. But pearl millet, it is 2 times less, 2.5 times less. And the other small millets, their test weight, 1000 seed weight is hardly 5 grams. It shows these are very small seeded crops. And as such, in cultivation, there are 9 crops, the number is increasing. The other beauty of the millet crops, all they are C4 crops. C4 crops have ecological significance because they lack photorespiration. And they can photosynthesize even by closing the stomata. It means the water losses through stomata is regulated in C4 crops, and the carbon is recirculated within the mesophyll cells and bundle sheath cells. But the C3 crops like rice, there the carbon dioxide enters into photosynthesis and there is respiration also. So the net photosynthesis is reduced in C3 plants because of the loss through the respiration. But the C4 plants are devoid of that water loss. Means they can produce at low light levels and also water inputs. And the efficiency is very high. Because of these reasons, the C4 plants are so-called millets. They are popularly grown in harsh environment where the soil moisture availability is very low and the temperatures are very high. These two are the characteristics of millets. They have small seeds and they have C4 mechanism so that they can grow in the harsh environment where temperature is very high. And the other important characteristic is they are very short duration, right from 60 days to 100 days. If there is drought, they can complete their life cycle even quickly also. Means this short life cycle is useful for complete their life cycle even under harsh environment like climate change. FAO recognizes 15 types of millets. Though this fonio, black fonio, white fonio, and also ricina, job steer, and teff. These are the new crops that are not there and under cultivation in India. And Guinea millet is also not there in India. I have put them with red mark here. These millets are there as per FAO, but their cultivation is not prevalent. So recently they are also being introduced in the country to capture the global markets. And see, in India case, 9 millets are there. Of these, sorghum, pearl millet, and also to some extent finger millet, they are pan-India crops. They are grown across the country in more than 5 states, and they are globally also they are having presence. But all other millet crops, remaining millet crops like little millet, proso millet, foxtail millet, brown top, barnyard, podo millet, they are having regional presence. only 1 or 2 states are cultivating in India, or some countries are producing. Suppose proso millet is produced by Southeast Asian countries and American countries. As a part of the celebration of National Year of Millets in 2018, Government of India has notified millets as the nutri-cereals. Earlier they called coarse cereals or millets, but in 2018 they have been renamed as nutri-cereals through government gazette notification. Through that notification, they have added 2 more crops, buckwheat and also grain amaranth. These are basically broadleaf weeds. Cereals are grasses, but these buckwheat and grain amaranthus, they are like nutritional qualities, just like millets. These two dicots have been added to the list, making total cereals or nutri-cereals to 11. Earlier, we are having 9 millets crops. These 2 cereals have been added as, now they have been named as the nutri-cereals. In 2023, we have celebrated International Year of Millets, and we have Food Safety Authority of India. It has also added some of the other millets that are grown globally, that is fonio, teff, jobsteer, and crabgrass. The crabgrass is grown in India to some extent in Madhya Pradesh. So altogether, now we are having 15 crops in India under millet group. And if you look at the global production of the millets, they are produced around 95 to 100 million tons are produced in the globally, and they account for the hardly 3 to 4% of the cereal production. But the major, if you look at the distribution of the production, Africa is the major producer for the sorghum crop, around 43% is coming, and pearl millet, Asia is the major producer. But for finger millet, India and the Africa are the major. So around 100 million tons of produced globally, various millets, and sorghum is the major, around more 55 to 60% of the millet production is accounted by sorghum itself. Around 30% by pearl millet, and remaining 15% comes from the all other millets. The next important being the finger millet, and buckwheat is the other 4th in standing. If you look at the millet distribution across the country, if you say, and the area is very high in America, you see the sorghum production, it is largely produced in USA and followed by India and some of the African countries. But the Australia and China and also South America countries are also producing, but their production is less than 1 million tons. If you look at the pearl millet production, Africa and India are the major producers, and kodo millet, South America and Mexico is the major producer. Foxtail millet is there in Europe and also Southeast Asia, whereas the barnyard millet is present in the only few countries. It shows the all millets are not cultivated across the country, but the global countries, but India is the producer of the most of the millets. In last year, we have produced around 17 million tons of millets, and the most around 65% is coming from the pearl millets itself, and the sorghum is contributing to nearly 20% of the millet production. Finger millet is having around 10%, and small millets hardly 2%. And if you look at the seasonal distribution of these millet crops, pearl millet and all other millets are mostly kharif crops, but sorghum is a rabi season crop. This anomaly earlier in 1970 and 80s, sorghum is basically a kharif season crop. But due to grain mold menace under continuous rains at flowering stage, it is a fungal complex disease that spoils the grains with fungal molds, and the grain becomes unfit for human consumption. That is why most of the kharif sorghum production is going either to the alcohol production or for the animal feed. For human consumption, especially in Karnataka and Maharashtra, where the sorghum is consumed as a staple food, the rabi sorghum has come up on a large scale. Though now the rabi sorghum has prominence, and Maharashtra, Karnataka accounts for the most of the production. And some of the varieties like M35-1 rules the consumer preference. And you see that they have around 35 million hectares millet area has come down to 13 million hectares. Nearly 60% of area has been lost. But there has been nearly doubling of the yields. On account of this, the production remained the same over the years. So in fact, it has increased in between 1980-85 because of increase in the productivity. But we are maintaining the corrective productive levels despite loss of the 60% of the area. If you look at the contribution of the millets to the total, it is occupying around 6% of the cultivated area in India and contributes about 5% of the food grain production. You are getting 330 million tons and the 17 million tons roughly works out to 5% of the pulp. And they contribute to very small amount of exports also, around 0.07%. Export earnings remain around 250 crores and around 50% of these 260 crores is coming from the Jowar export itself. Now, if you compare why these millets are having less than 1 ton of production. These are the various food grain crops, rice, wheat, and maize we are growing across the country, and pulses and oil seeds. They are having slightly higher yields. Oil seeds are better than millet products. If you work out how much income is coming from these yields of the millet crops, among these crops, maize is having only from grain sale we are taking, highest income is coming from the maize crop. But among the millet crops, finger millet is having higher income. Sorghum, pearl millet and all millets, they are having around 35,000 rupees. You know that none of the crop can be cultivated on hectare with a cost of cultivation less than 30,000 hectares. Means the income coming from the millets is not sufficient to support the farmers' economy. They are not profitable. They can feed their bellies, but they cannot feed their money requirements. So these millets productivity, despite 2 times increase, their production is not economical based on the grain sale. The reasons are the millet crops are not procured. You see, in India, 50% of the rice and nearly 40% of the wheat is produced by the government at the minimum support price. But in millets, only 2% of the millets produced are procured by the government. This is not only that one, there is also a problem coming from the public distribution system. Government of India has introduced 2 rupees kilo rice and wheat program. When rice and wheat, milled rice and wheat is available at 2 rupees, and who is bothered about purchasing the millet crops, grains at 30 or 40 rupees, and their flow at 50 to 100 rupees. So this is the anomaly. You produce them, but they are not being deliberately made by the market mechanisms, less profitable and not reaching the consumers. And you see the distribution of the cultivation, and there is a pearl millet crop, it is on Western India, and sorghum is distributed in Central India and Southern India, whereas this finger millet is there in Karnataka and Uttarakhand, basically. There are also there in Odisha and Maharashtra and Gujarat to some extent. Means the millet crops are not grown on all states. On a small scale, millet crops are grown on Northeast India also. You see how these millets are confined to few states. Only 5 states, in case of pearl millet, Rajasthan and Uttar Pradesh, Gujarat, they account for nearly 70% of production. Maharashtra, Karnataka, and Rajasthan, they account for nearly same situation for the sorghum. For pearl finger millet, Karnataka is accounting nearly 2/3 of production. In small millets, Madhya Pradesh is the major producer. Means their few states are producing the millet systems. Means their distribution to reach the consumers is a transport cost and overhead marketing costs are involved in these things. Now, the millet crops, they produce the food material for the poor people, and also there are consumers who are there, allied, they also their food habits cannot deviate from the barrel millet. In case of Rajasthan, jowar or sorghum in case of Maharashtra and Karnataka, and finger millet in case of the Karnataka. Not only the food needs are met, but they also produce biomass stores that supports the livestock. Livestock is part of our farming systems, especially in rain-fed areas, and the green fodder is not available in rain-fed lands, and the stores support the feed requirements, and they support the livestock, and the farming systems are revolving around the stores. So in drought years, these store, especially jowar and pearl millet, they command more price than the grain. Means in from Haryana and Rajasthan, the pearl millet store is imported towards the other states where millet fodder shortage is there. That shows during the drought years, millet store command prices, better prices, and farmers and economy gets improved. And you know that millets, they are grown on hilly and tribal areas, and tribal consumers are very important because they don't have other alternate sources of meeting their food requirements. Millets will be contributing to the food security of the tribal and poor people in the hilly and tribal regions. And the recent trend is because lifestyle diseases are coming up like arthritis and also heart diseases, blood pressures. These people who are eating now till date the rice and wheat, and they have become diabetic, and also some of the other health issues like the heart diseases. Because of the high protein content and nutrient profile, millets are seen as a medicinal foods. And that is why it has been proved that when you are consuming or integrating millets into your diets, the heart diseases, all the even diabetic or these blood pressure problems are disappearing. That is why basically till now, we have seen earlier slides, these are the tribal people crops or the poor people crops in rain-fed and dry land areas. But looking at the health benefits of millets, elite consumers are coming up to eat these. Now you see in markets, the per kg prices, if they are organic produce, 500 rupees. If non-organic, 150 to 200 rupees. On one side, the producing farmers are not getting even 35 rupees per kilo, but in market, the consumers are purchasing at 4 to 5 times higher side. This price difference or price spread between the producer and consumer is exploited by the marketing channels or middleman. Once you build up these price gap between the producers and consumers, and the millets become more profitable. And this is the scenario about the millets and their contribution to food security. Ever since we have started agriculture on the deglaciated lands, and there is increase in industrialization, urbanization in mid of the 18th century. With that, the carbon dioxide releases and the other greenhouse gas emissions are increasing. And with this, the global greenhouse gases that are around 300 ppm carbon dioxide at around 1900 AD, now we are at 430 ppm level at the global level. Even in India, the carbon dioxide level in atmospheric carbon dioxide is 425 ppm. Once the carbon dioxide, not only carbon dioxide is increasing, but the temperature is also increasing by around 2 degrees centigrade. And this increase in temperature and carbon dioxide has increased the metabolic processes in the plants, both C3 and C4 plants. Some gets disadvantaged, some gets advantaged initially. When combined both carbon dioxide and temperature, most of the benefits are on negative side. And in this context, millets fits well. And you see the example, there is drought because of the climate change, drought, number of events are increasing. Now you see El Nino after every 3 to 4 years. Last year is El Nino year in India, where because of the Pacific Ocean unusual heating, Indian monsoons gets reduced. The amount of rainfall that you receive from the southwest monsoon reduced. So the food production and also the other livestock production systems greatly reduced. The other anomaly is that there is floods are also not only decrease in rainfall, but also floods are also increasing. You see the sea level is rising. Now you see the Thailand, they have to shift their capital from the because of the inundation in the water. Now, if you look at the Kerala is supposed to be a heaven on earth with promising climate, cool climate. But this year, if you are saying the cardamom crop has dried up because in February there is no rainfall and all the crops, even including cardamom is the major crop that has been affected because of the drought. The other plantation crops, including paddy, has been affected adversely because of the moisture supplies. If the paradise on the heaven on the earth, like Kerala state is suffering from the drought, what about the other states like Gujarat or Rajasthan, where the rainfall itself is basically very low and less than 300 mm. The summarized effects of this one, there is increasing temperature, increasing carbon dioxide, and varying rainfall. Because of the high temperature, the water losses by way of evaporation and transpiration is increasing from the croplands. Transpiration losses are very less because crop consumptive is hardly 1%. Evaporation losses are the major culprits that are going to get enhanced under climate change. And because of high temperature, the crop duration gets reduced. Suppose the crop currently is maturing in 100 days, they get reduced to 85 days. Means 15 days crop duration is reduced. Accordingly, crop yields get reduced. Because of the high temperature, the time taken by the insect pests and the pathogens get reduced. Suppose a stem borer is there, it completes its life cycle in 4 weeks at current temperature. Under increased temperature, they are completing the life cycle in 3 weeks. Means more number of pests are coming, pest generations are there. So the crops gets infested with more number of pests. The other one is weeds are more competitive to the crops, and though they compete more effectively for water and nutrients, and they reduce the crop performance. These are the things by which the crop performance is adversely affected under adverse conditions. Now, this is the climate representation. I have already told droughts are there, floods are there, heat waves are coming, and also seawater level is increasing. Because of this, all the livestock sector gets adversely impacted, resulting in their low production and thus food security at the country level as well as the household level gets damaged. And this is example I wanted to show in India how the mean temperature is rising every year. This red area shows there is significant increase in areas by 0.1 to 0.2 degrees centigrade in these. Every year, this much temperature between 1951 to 2000, this much is the rate of increase in the temperature. The other one is, if you see this one, the greener areas, this rainfall is decreasing, significantly decreasing in these greener areas. Means this part is having not much area, this is decreasing. This greener part is increasing, this brown part is decreasing. Though central India and southern India, western India, and also northeast India, the rainfall is decreasing. And these means there is increase in temperature, there is also decrease in the rainfall, and some parts are experiencing. This is the temperature trend in India, both annual, southwest monsoon and Rabi season temperatures are increasing month by month. We are seeing this one. These are the rainfall distribution. They have worked out the number of rainy days are significantly increasing. Red color shows the increasing trend of rainy days across the country in India. And there are not only increasing the temperature, but also number of events which heavy rainfall is coming. 6 to 12 mm of rainfall is coming per day in short time. And you see that in Bangalore or even Hyderabad, if there is 1 hour rainfall, there is floods or on roads, traffic snares are coming and people are suffering in a lot because this is a urbanized system. The entire is a concrete jungles. There is no water going, seeping or infiltrating into the soil. Entire rainfall gets generated as a rainfall. That is why you are getting the problems in urban agglomeration. But actually in agriculture situation, the water will be getting impregnated. But if you are having heavy rainfall events, that goes as a runoff. There is need to conserve these things. Now, the heat waves are also coming. Now, you see the every day in paper say that 49 to 50 degrees centigrade. These are some drought years where the temperature is increasing. The other important thing is drought year is and the high temperature heat waves are positively correlated with the El Nino. Means wherever the rainfall is very low in a particular year, the temperatures are increasing on large scale and people are also getting affected. Some are dying. Number of people dying because of the heat waves are also rising in this. And the other anomaly, if you say, the seasonal distribution within the crop season, there is a distribution of rainfall is changing among the months. Till now, we have developed the production practices for a crop based on the existing rainfall pattern. Suppose if you are seeing Anantapur, that is a arid zone, the rainfall is less than 400 mm. You see the August month, the rainfall is increasing between 1991 2000. This red color shows in August month there is increase in rainfall, but this July month, where most of the sowing happens for the crops, there is decrease in the rainfall. Also the November and December. And if you come to Bangalore, other example, there is increase in the rainfall in June and July up to August. But in September month, rainfall is decreasing. Means the location wise, the rainfall pattern is changing. Bijapur is the other example where the rainfall in July month is decreasing. Means the current production practices or sowing in Kharif season, which you have taken up, needs to be modified with suitable mechanism. Seeds, you have to either shift it, advance the sowing time or delay it, the sowing to the next month of this. This is the rainfall variation. Now, if you look at the vulnerability of the India as a whole, South India is most vulnerable for the drought, flood, as well as the cyclone. And these are the things, if you look at for drought situation, Southern India is highly prone and Western India. But if you are looking for floods, Southern India, Northern India, Eastern, this means the country is prone for not only floods, but also drought simultaneously. You have to cope up with both the excess moisture as well as the low moisture in the. This is the drylands where the temperatures, this is semi-arid and arid regions in red and brown color, where these crops are grown under harsh environments, their moisture availability is very less. Now, wherever the monsoon rains are getting reduced in a particular year, food grain production is changing up to 10%. The maximum reduction has been seen in 2002, where the production has been reduced, food grain production has reduced by nearly 14 to 15%. But in 2009 is also a drought year, but the production decreases despite of the around 15 to 20% rainfall departure. The production has, the food grain production has not decreased much. You see again 2012 and 2014. These are drought years, but in 2017 you see around 5% moisture deviation is there, but the food grain production is not much affected on positive side. It shows over the years, India has developed a mechanism by which it can sustain the climate change impacts on food grain production. Earlier, you might have heard 1905 droughts are there because of the potato, late blight of potato, or even drought, like different events are there because of which your institute like IRI, even ICR has come up into existence in 1926, and every ICR or SAs have been established to develop drought resistant mechanisms. And if you see the carbon dioxide impact and the temperature impacts on a crop, you see the biomass production is if it is 400 ppm of carbon dioxide and the temperature is 37 by maximum 31 is the lower, the yields are going to be reduced by 50%. Here you are getting 40.6 grams of the biomass in a maize crop at current level of temperature, 25 degrees and 90 degrees, 400 ppm carbon dioxide. If the temperature is increasing by nearly 50% to the 37, the biomass production of maize crop is reducing by 50%. If the carbon dioxide concentration is getting doubled in future environment to 800 ppm, and the impacts are going to be the same, nearly 50% reduction is there, and these reductions are because of the reductions in root, leaf, as well as the stump biomass. Means the production of the crops is going to be reduced under high temperature and high carbon dioxide environment. You see, this is a sorghum crop experiment where currently you are getting 4.2 tons yield at Parpani, and when there is a 5 degrees centigrade increase in the temperature, even on 10% increase in rainfall, you are going to have 1.5 tons yield reduction. And if rainfall is decreasing by 10%, the decrease is another 2 quintals. Means nearly 60% is the productivity realization because of the combined impact of the reduced rainfall and high temperature. The other thing, as I have told earlier, is the crop duration. If the sorghum crop is coming maturity in 100 days, that this is example from Aurangabad in Maharashtra. The currently it is crop is maturing 100 days and yields are 3 tons. But when temperature is increasing by 5 degrees centigrade, the duration gets reduced by 20 days and the yields are going to reduce by 60%, 56 to 60%. Means the impact of the climate change is negative on most of the crops, including millet crops, which are having C4 mechanism. The negative effects are more in C3 crops, though the initial increases in carbon dioxide enhances their production. Increasing temperatures negates that increases in food production of biomass, neutralizes, and the yields are getting decreased in all the crops, and the decreases are more in C4 crops. Now we are going to look at how the millets needs to be made climate resilient. This graph shows that in all crops up to 35 degrees centigrade, the photosynthesis, the green line, this is the red line is the respiration. Photosynthesis is more than the respiration. Means there is net photosynthesis or biomass production up to 35 degrees centigrade. Once the temperature of the crosses 35 degrees centigrade, the photosynthesis decreases or the respiration outpaces the photosynthesis. Means whatever the biomass is there, stems and leaves, they are utilized for the respiration and there is no grain production. Means biomass is produced, but that is utilized for the respiration of the plant processes, and there is no grain production ultimately in that particular crop. So the temperatures, once you cross beyond 35 degrees centigrade, here the C4 crops are going to suffer, and the photosynthetic rates, it is crossing 50 degrees centigrade, there is no production, neither respiration, plant will be dying. Means these gaps, you have to fill these gaps in the C3 crops, and also how to enhance this gap between more to put the photosynthesis on higher side compared to respiration in millet crops. So millet crops have advantages of C4 mechanism. So this gap is if you widen the more photosynthesis and less respiration with millet crops, they can occupy the areas where currently millets are not grown. Suppose in Rajasthan, pearl millet is grown on extreme Pakistan border. But other side, towards the Delhi side, maize crop is cultivated or rice crop is cultivated because water resources are available. Once their water resources are getting decreased because of high evaporation losses, the area water available for cultivating rice and maize decreases. So to produce more or the food required for human beings in that Rajasthan ecoclimate, more millets like pearl millet will be cultivated. So the areas where water resources are decreasing, the millets are going to occupy them, including maize crop. Now we are going to look at, we have seen what is the millets importance in human nutrition, how the millets are affected by climate change, though the impacts of the climate change on millets is less magnitude compared to cereal crops. They do subjected to climate resilience impacts to a lesser extent. Now, how climate practices, resilient practices will make the production of the millets without losing much of the productivity, we are going to look at the what are the climate resilient practices. Resilient means able to resist the changes because of the external pressure of the whether it is climate or water or temperature, it is able to resist. That mechanism we have to develop. That is climate risk means resisting practices that overcome the impact of the climate, changing climate. That practices, what are they, how they are applicable to millet crops, we are going to discuss in the next 15 to 20 minutes. This climate resilient agriculture or climate smart agriculture, it aims at enhancing the productivity of the crops. Through adoption for that, to produce more, there needs to be adoption mechanisms, whether it is various production practice, adjusting the sowing dates, or using the mulches, or using fertilizers, or the anti-evaporants, or water harvesting, various adaptive mechanisms you have to bring to enhance the productivity. The first two are the mechanisms to ensure the better or food security for the existing population. But the other one is, you have to have a good climate where for the future generation, our children, grandchildren can live. For that, you have to reduce the greenhouse gas emissions. So either the paddies where rice crop is produced under particular conditions, or the livestock produce entero mechanisms, their livestock nutrition mechanisms have to be improved, or their paddies, puddled rice cultivation needs to be shifted towards the aerobic rice or the system of rice intensification. So the millet crops and their contribution to greenhouse gas emissions is less, and their the coping mechanisms by adoption is also has less impact in reducing the greenhouse gases. So whatever the greenhouse gas reduction mechanisms, they applies to the crops where the heavy fertilizer inputs are there, or rice crop, livestock mechanisms. But the first two mechanisms, enhancing the productivity of the crops through adaptive mechanisms, applies to every crop, including the. So these three are the core principles of the climate resilient agriculture. Now, in climate resilient agriculture, or villages or farms, you have to look at all these 6 points. One is weather. You have to take what is the weather that you are now. Weather predictions are coming, long range weather, long range, medium range, and short range, and every day also. Hourly weather predictions are also coming. Suppose the government of India predicts, thus this coming year is a El Nino year, so rainfall is going to be less. And for that, that is a warning system given by the government that weather is not going to be favorable for food grain production or crops cultivation. Accordingly, which crops needs to be cultivated, because the water, based on the water resources that you are having, and what are the inputs, that seed inputs or the insurance mechanisms that needs to be arranged, can be looked at in advance based on the long range weather forecast. And the crops, not only weather smart, they needs to be water smart also. Means they should use less water for the production of the grains, food grains. The other one is carbon smart. Low amounts of carbon emissions should be less, and they should be carbon conserving crop production system should come, so that maybe agroforestry system, conservation, various practices are. Means fertilizer smart, means you have to use the cultivars that are efficient in utilizing the either nitrogen or phosphorus, or you have to go for the biological fertilizer. Biological, this means microorganism based fertilizers, or even biological nitrogen fixation mechanism. They needs to be strengthened. And if you look at the biological nitrogen fixation, because of the increase in the temperature, the legume nitrogen fixation is going to be reduced, and also the microorganisms in the soil, their biodiversity get reduced in the soil, and thus their nitrogen or the other nutrient fixation or mobilization potential gets reduced. So you have to go for the seed treatment with the potential microorganisms. Now the carrier-based biofertilizers have given up to liquid-based biofertilizers and seed inoculation. Even some of the millet crops, the biofertilizers are sprayed at flowering stage. Means nutrient smart mechanism has to come up in climate smart mechanism. The other one is energy. Means you have to use energy efficiently. Whatever is there, you have to go for mechanization, or you have to go civilized way of growing the crops. You know, most of the weeding is done by human beings, manual labor that can be gone towards herbicide usage or even the conservation agriculture or precision weed management, such solution. Energy smart agriculture has to come. Knowledge smart. What is the opportunities? Is there farmer for marketing the produce? Which produce is required on large scale? What is the price mechanism in future? What is the marketing channels or the farmer producer organization? These 5 mechanisms have to be looked at in the changing climate scenario to make the production system smart. Now we are going to look at these climate smart practices adaptable to the a millet system. Now you see the climate smart practices, there are 6 to 7 practices. One is the water harvest. You have to water where the water is falling, you have to harvest them into structures, maybe underground structures like maybe so that the cuddings, you say in Rajasthan, the rainwater is harvested into underground wells for drinking purposes of human beings as well as the livestock. But in other southern India and central India, they are harvested into farm ponds or the wells. The second practice is the conservation agriculture, zero tillage. You have to reduce the tillage and retain the crop residues and continuous crop cover is there so that the reduced tillage reduces the organic carbon decomposition. Soil organic carbon, once you plow that one, they gets exposed to temperature and breaks down. That is a loss. If you don't plow the land or plow only to zero tillage or no tillage or minimum tillage, the carbon losses from the soil is reduced. And you put the mulches on the soil, crop residues or even plastic mulches are coming. You know that plastic mulching is, rice cultivation is practiced in China on large scale. 5 to 10 million hectares of rice is cultivated under plastic rice. Even in Korean Peninsula, rice is cultivated under plastic mulches. So that you know that we produce rice under puddled soil with 5 to 10 centimeter standing water. But once water become limited, the people are shifting towards producing the rice crop itself under plastic mulches. You see what is going to happen, the food production systems in these things. And you need to have continuously look at the weather situation and weather forecast, as I have told you. And the organic farming is other way of producing things. Suppose under climate change, you cannot use the more fertilizers, the crops are suffering. You go for organic, for low input agriculture, where the health is involved, the gets improved if you are consuming chemical free produce on one hand. The other hand is they are continuously supporting if you are building up organic carbon in the soil, on increased organic carbon, water supplies increases to the crop, and on increased water supplies, better crop growth and yields are realized, and these more microorganisms are attracted on organic carbon in the soil, and whole chain of life cycle is developing on organic farming or organic carbon in the soil, so that the climate impacts on the farming gets reduced. So try to resort where the organic farming is possible, where low input crops like millets, where the fertilizer use is hardly 50 kgs. We cannot advocate organic farming maybe with rice crop or wheat because they are filling our bellies for the country. If we go for organic farming, there is drastic reduction in the immediate vicinity, just like Sri Lanka. They have gone for organic farming, thinking that they can export everything, and they have collapsed system. So blank organic farming is not recommended, but organic farming for low input crops, low fertilizer using crops like millets, even pulse crops, oil seed crops that are grown with low inputs, they can resort to the organic farm. And you have to look at the soil health. If you are not having good soil, they are not going to make good production systems. For that, the various mechanisms have to be resorted that we are going to look. Reducing the livestock, even crop emissions, greenhouse gas emissions have to be earlier. This is the last practice which has to be addressed at a country level with proper policy, but all other practices of these 7 practices can be adopted to make climate resilience production systems in the country. And if you see the crop rotation, of course, you rotate the legumes with cereals or the high input crops with the low input crops. These are the 7 practices. They need to be adapted based on the requirement of particular location, and they need to be integrated in the production systems in the country so as to bring climate resilience in the country. Now, if you look at the rainwater harvesting, if you say even in the driest part, in Badmer, in Rajasthan, Jodhpur, there is rainfall. 10, wherever the rainfall is more than 3 to 5 centimeters, at least 10% of it, rainfall gets as a runoff. Even in a sandy soil, small scale, the water is moving, not on large, but in other soils, other than sandy soils, if you are having 5 mm or 5 centimeters of rainfall on particular event, around 20% of the runoff gets generated. So that runoff you have to capture, because the rainfall is varying across the months. Whenever the runoff gets generated in a farm landscape or a village level or a watershed level, the runoff water has to be captured, and they have been safely tunneled into a water storage structure, be it a check dam, farm pond, or even other, anyway, the underground structures or even wells are there. This rainwater needs to be tunneled into we have to direct these runoff water, you have to capture, tunnel, and safely storage into the structures with the farm ponds. The farm ponds also, huge evaporation losses will be there. That evaporation, anti-evaporant chemicals like petrol or kerosene or even the crop residues keeping on the water body will reduce the water evaporation losses from the farm ponds. This is the first practice we have to do for successful agriculture in the dry lands and also in the areas where there is vagaries of monsoon to make the farming sustainable. And if you look at the runoff estimates from the millet regions, and if the rainfall, it has been estimated in areas where there is 50 centimeters of rainfall, huge rainfall runoff gets generated. And it has been estimated around 30% of the rainfall is generated as a runoff in verticals and horizontals of central India. Central India, Madhya Pradesh, Maharashtra, Karnataka, here major millets are cultivated. And even the western part of Gujarat and Rajasthan comes under the central India. Here verticals and alphizals are there. Here you can anticipate around 30% of the runoff during the crop season. That you have to collect. And it has been estimated 2.2 million hectare meters of runoff water can be harvested from the millet growing areas of 8 million hectares. That is the area they have estimated. From this runoff harvested, if you are putting them in proper structures, around that can give irrigation to nearly 3 million hectares of crop during a drought can be given one irrigation. That can increase the production, that not only the drought impacts are negated, but can increase the productivity by 0.4 to 2.5 million tons. Means runoff is the key for millet cultivation and changing climate. You have to harvest them and you have to give as a supplemental irrigation you are harvesting nearly 2 million, you can harvest 2 million hectare meters of water. And if you provide one irrigation at critical stage, maybe at flowering stage or grain filling stage, if you are, or if it is essential at crop establishment stage, it changes the fortunes of crops and also the farmer's income. So this is the capture the runoff, where it falls, store it properly, and ration it at appropriate crop stage. Now, the other module for overcoming the climate, now till now, one is the runoff based farming. The second module for the climate resilient agriculture is the conservation agriculture. Means you reduce the tillage. You say till now people have blindly tilling, summer plowing is required. But summer plowing needs results in the whatever rain is coming, that gets evaporated. Plowing increases the runoff, the water infiltration into the soil, no doubt. Even if you are not plowing the soil, rainwater infiltrates. But if excess water is there in drylands, that needs to be captured as a runoff. So there is scope for reducing the tillage aspect in the drylands, so that the runoff is generated, that it will be captured into water structures and for proper use. And you cover during cropping season, you need to cover the soil with the crop residues. At least 30% of the crop soil is covered with the residues, then it is called conservation. What is conservation agriculture? If you ask me precisely, reduced tillage with 30% of the soil covered with the crop residues. What is doing with these crop residues? They are moderating the soil temperature. If it is a winter season, the soil temperatures gets increased for the better growth of the crops. If it is a summer season, the cushion of the heating sun effects on the soil by lying as a barrier between the soil and the sun, and they reduces the soil temperature by 3 to 5 degrees centigrade. So this cushioned temperature reduces the evaporation losses. Means from a soil where the crop is growing, 90%, 95% is your evaporation losses. Transpiration losses is hardly 1%. Consumptive use, that includes transpiration, photosynthesis losses, is only hardly 1 to 2%. Means 97% of the water is going as a evaporation. That is why mulching is crucial for conserving the moisture that is coming from the rainfall. This is the second principle. The other one is in drylands, once the crop is harvested, livestock is grazing and there is nothing green cover crop. So that otherwise, if something is there, the sand, winds are, erosion is occurring because winds are there, they lift away the soil part. If rain is there, untimely rain is there, because there is no crops on the soil gets removed, erosion is there, both from the unsolicited rain events or the winds in the drylands. To overcome these things, you have to retain the crop stubbles. In drylands, you cannot expect a crop to be grown either as a green manure crop or cover crop because moisture is not there. So you have to retain the crop stubbles. If it is sorghum is there, sorghum stubbles needs to be left. Pearl millet is there, or even small millet crops. You harvest the grains only, you leave the crop stores as such, so that if winds are there, because of the standing stubbles, they cannot lift the soil part. Even if rain is there, they cannot continuously take up the runoff erosion. They can be prevented because of the standing ground. So the second weapon available with the farmers is the resort to the conservation agriculture in the drylands. Now, as I have told you, organic carbon is the fulcrum, that is the center of the attraction. Unless you improve the soil organic carbon content, the crop production in drylands is going to become a challenge and the productivity is going to decrease. So if you are applying FIM, because of increased temperature, the carbon dioxide, they gets converted into carbon dioxide and they go it is a wasteful process. Under high temperature conditions, If you are applying continuously organic manure, FYM, they gets lost, decomposed, and carbon dioxide is lost into environment. That is why in tropical countries or tropical environments where temperatures are very high, organic carbon buildup is very difficult because temperature is very high, the amount of water is available in the soil is very less. So the carbon added as a FYM gets lost by decomposition. So to overcome this practice, now we have to look at the generation of either you use the crop residues directly incorporate into the soil as a conservation agriculture components. Once you are retaining them as a mulches, continuously year after year, if you are adding mulches on 30% of the soil area, they get decomposed slowly on the bottom layer and carbon buildups that has long period of residence in the soil. On the top side, you are having the undecomposed crop residues added in the current year. On the bottom side, you are having the decomposing residues. And in that context, in this way, if you are using the wide CN ratio materials, just like jowar straw, carbon content is 60%, nitrogen content is hardly, carbon content is up to 60%, nitrogen is 0.5%, means 60:1 is the C:N ratio, means that they cannot release the nutrients for loss by decomposition. If you add the crop residues, they remain in the soil for longer period. How, if you are adding these crop residues, the practical experience shows the termites are building. You say that you should go for the conservation agriculture in drylands where unless the temperatures are very high, the termites are coming up on large scale, and you see in IRA soils, even in the soils in Rajasthan, wherever if we are going for continuously addition of these crop residues, termites are building up. Once termites comes up, everything is gone. Termites are entering even your households nowadays. If you are wooden structures, doors are eaten by that one. The tree which is having 1 meter diameter trunk, it gets killed over years, means see the power of the termite. Once it enters into the plant trunk or the roots, it can destroy a plant which is having 100 years age in hardly few years. So what is the solution? We are saying that organic manures, they decompose and release carbon dioxide, and it has to be alternatives required. And we have told that crop residues, we incorporate them. Crop residues are, it is not, these termites is not problem everywhere. If the problem is there, you have to look at the alternatives. So wherever termites are coming because of the addition of the residues directly into the soil, there the solution is the biochar production. Biochar is produced under anaerobic condition, just like without air. These crop residues are burned, and you produce the material with high carbon. So these biochars, this means they are rich in nutrients, because whatever the carbon material is there, our oxygen got burnt because of the heating, and the more mineral nutrients and the carbon is retained in the organic, this biochar. So biochar cannot be attacked by the termites. So now the solutions is apply wherever is possible the manures. If not possible, the temperatures are very high, go for application of the crop residues. If termites problems are there in your situation, you go for application of the biochar material into this. The biochar medicine, if you are adding, they have improved the productivity of the experiments. Research findings have shown that they can improve the water holding capacity of the soil. Nutrients are supplied over years, and they have long residency period. Biochar can stay in the soil maybe up to 20 to 30 years, and they can hold the water up to 20 times of their weight. Means in dryland conditions, if you are applying 1 ton of biochar, it is going to hold 5 to 10 tons of water in their soil. Otherwise, in a sandy soil, it cannot hold water. Either gets percolated or runoff goes, nothing will be there. In sandy soil, if you are applying this biochar, it at least holds, even in the root zone, when you are applying, if not able to apply the biochar for entire field, you apply for the root zone, 5 to 10 tons of biochar, And that much of water, if you are 5 tons you are applying, 25 tons of water is retained in the crop rows. So that water will support the crop plants to some extent and more production is. I have told you that mulching you have to do. The other one is nowadays in drylands, this hydrogel, Pusa hydrogel, it is a high C material. It holds a lot of water. 400 times of weight, the carbon, this hydrogel, Pusa hydrogel, if you are applying 1 kg, means 500 liters of water is held by the 1 kg of hydrogel. If you are applying the 5 kg of hydrogel over hectare area by seed treatment with the various crops in the crop rows, 5 kgs means nearly 2 to 3,000 liters of water is there in the crop rows. So the water is released at a subsequent stage. If the crop is suffering the water stress at seed, if you have sown the crop, there is no water, and this material, the hydrogel that is having water, is released, taken up by the seeds, the crop germinates successfully. If crop germination is successful, the subsequent rains are coming and water is held by these hydrogels and they will improve the materials. The recommendation have come up, especially in Bajra, if you are applying 5 kg biochar, this hydrogel, Pusa hydrogel per hectare, around 15% increase in sorghum, this pearl millet production has been observed in the across the pearl millet zones, and the economy is more in the Rajasthan region. I have told you that you produce the vermicompost with or the crop residues, decomposed materials. Composting technology is the other one which aids in enhancing the water supplies to the now. So we have seen how the water can be increased in the soil by enhancing the organic matter, adding the organic matter. But once the rain is there, you can make the soil changes in the soil by making the subsoiling. So it means we are opening a slight small slit with this tractor up to 1 meter. In this area, the water will be retained. This is the no plowed area and this is the line opened. In this area, water gets absorbed. And this is in Maharashtra, they have fully check basin farmer has been developed. They interbasin, they have 5 meters length when bed is prepared, where on all sides you are having bunds. Whenever rain falls, that water is retained into these beds. And this is a tractor run implement. And in by these mechanisms, you can increase the water retention, water percolation into the soil. The other one is the land configuration. You know that the broadbed and furrow systems, they have been successful in rice wheat cropping systems, even under conservation agriculture. But wherever rainfall is very high, low, and the broadbed and furrow systems with the barriers in between, whatever rainfall is coming, that can be retained in between these furrow area, and bed area will be crop will be growing. So other way is, you know that the lands in drylands are highly undulating. There is a slope up to 10% of slopes are also common in these areas. Means wherever possible, these heavy soils are you are having vertisols or all other sandy soils. The land leveling is of little significance. But in vertisols or where the soils are there, if you are able to do the laser leveling for there the whatever rainfall is there, that is evenly distributed, and the application of the conserved water through irrigation also becomes easier. However, land leveling is not required if you are going for the sprinkler irrigation system. But if you are resorting to flood irrigation based on the conserved water, their land leveling is required. Other you have to go for the sprinkler method of irrigation. So the landscape requires a contour bending where the steep slopes are there up to 30%. You have to go for you cannot say you go for laser leveling on a hilly area. Means you have to see how much slope is there. If it is less than % slope and soil is heavy, their laser land leveling is possible on a farm to farm level basis. But if the slope is very high, you have to go for the other soil water conservation measure, either contour bending terraces or all other whatever is being done in northeastern states or hilly areas of the things. And if you are going for laser leveling, the water use efficiency and the yield of the bajra crop has been nearly increased by 40%. Not only water use efficiency and also nutrient use efficiency also gets improved once you are going for the laser level. These are the impacts of the even the laser leveling proved promising for the sorghum crop, both in terms of grain yield, stover yield, and also the economics. Now we have seen that you have resorted to more water retention to the soil through organic manuring or conservation agriculture or soil water treatment, including laser leveling or terracing or bunding practices. Now, the other important practice that needs due attention is you have to put the farmer should be continuously aware of the weather system. What is the weather? Suppose you have seen not aware of the in Rajasthan, well millet crop is harvested today. There is 20 mm of rainfall on the next day. So entire crop that is on the ground is inundated with the 20 mm of water on a heavy side, and huge loss has been incurred by the farmer. So the crop harvesting or whatever is the field operations, for that, the farmers should be made, maybe they should be enabled to have the weather information at their disposal. The KVKs, nowadays around 700 KVKs are there. Now they are going to make even 1500 KVKs are there, going to become, or even now the farmers are getting the weather data or mobile. Now mobile is there, all mobiles which are sophisticated mobiles, not only a voice call message. Now you can have the weather information at your mobile itself. So there is need to develop weather forecasting mechanisms, how much rainfall is going to come next week or next 10 days, so that you can plan your rainwater harvested to give a irrigation. Suppose you have harvested a 1 lakh liter of water, and you don't know tomorrow is going to rain. And if you don't see the weather forecast and today you have irrigated the water that is there in your farm pond, given irrigation, and tomorrow there is rainfall, and you have lost your water that is stored in the farm pond as irrigation, and rainfall has come, that cannot generate runoff and fill up your farm. Means weather forecast is crucial for the water use and water harvesting systems, and also the pacing of the farm operations. You have to take up the spraying operations. Suppose you wanted to spray a herbicide, up to 1 hour there should not be any rain, and you have sprayed the crop with a manually from morning to evening by investing 2000 rupees per hectare. Immediately there is a rain, the impact of the herbicide has gone. But the same is the case with the insecticides. You have sprayed some insecticide to take care of the stem borer or shoot fly or whatever is there in particular crop in disease. There is immediately rain. So the farmer has to educate himself how these agromet services about the rainfall, temperature, or the other events for his benefit, so that farm operations can be scaled up, taken up for the advantages. Now, the KVKs, as I have told, they have to reach to the farmers and farmer advisors. They have to give, and nowadays the KVKs are reaching to the farmers. They are on mobile advisories. They are mobile advisory services. They are sending to each record. You register with the KVK that I need the farmer agro advisory services. So once you register with the KVK, other agromet providers, you are getting on your mobile every day. You are going to have your information, what is going to happen with respect to temperature, or there is rain, or there is heavy winds, high temperatures, what farm operations can be done, how you have to take the various operations. In this, the KV's case will play a key role, and Government of India is increasing the automatic weather stations presence even at the village levels. The automatic weather stations are established by across the country, even at the village level, because nowadays crop insurance is becoming a part of the adverse climate overcoming mechanism. So government is, if you are taking a loan from the bank, they are cutting the insurance for 1% or 5.5% crop loan you have taken, they directly cut the crop insurance component, besides the processing charges. But because of the flaws in the loss estimation for the crop, because of the adverse climate, the farmers are not getting reimbursement. Suppose you are having a car, you have taken a insurance or for your life. If something happens there is an accident for your car, the insurer will bear the cost of that. Suppose you are having health insurance, if you go to hospital, the insurance provider will bear the cost of your hospitalization charges. But despite the farmers are paying crop insurance charges from their lands, or the government of India is already taking a mechanism. Government of India is paying crop insurance to these insurance providers, but they are not reimbursing the farmers if crop failure is there. So there is a need to have a marriage between the weather advisory services and also the insurance mechanism. The insurance, if crop insurance is taken from you, our government has paid for that one. The crop cutting experiments at the village level, if the village level itself, the farmer is suffering, we don't expect each farmer level losses are there, they can be compensated. So if village level, because of the drought or some incidents, the crop has got damaged, then the insurer must pay so that the farming will become climate smart. So you are utilizing the advisory services, your insurance mechanisms to overcome the drought impacts, adverse impacts of climate change. These mechanisms are not properly established currently, especially crop insurance mechanisms. But in future, these crop insurance mechanisms are going to come on large scale in drylands. Even the private players are coming in coming years. Maybe the Reliance people, like any people, these people are going to come and they will be supporting the farmers. They will come to the rescue of the farmers who are affected with the dryland situation. Now you see, these are the crops, organic farming, and these are the crops where you can grow them on organic mode. Who is somebody is writing on the screen? Please don't do this one. It is disturbing me. Somebody is making circles on the screen. Who is doing this one? Please don't do these circles. So organic farming is other one, because these millet crops, the fertilizer is very low. And you see, the fertilizer used in the pearl millet crop, that is 60% production of the millets, it is hardly 30 kg per hectare. But these small quantities of fertilizers can be met from organic sources. In small millets, there is no fertilizer application also. So these two small millet crops and the other pearl millet and sorghum crops, where fertilizer use is low, they can be resorted to organic mode of production. And organic mode of production, the hilly areas and tribal regions are very apt for their cultivation. And however, there is need to these organic produce, their mechanism should be established to get good price. Otherwise, the organic farming, taking organic farming further will be difficult in this. You know that there will be heavy rainfall in particular place. Even in recently, you might have heard in Saudi Arabia, there are floods. This is a sandy area, Saudi Arabia. They have gone for cloud seeding to have some rainfall, and the cloud burst is there. Because of cloud burst, even in sandy soil, floods have been generated. Means it is possible to have floods even in a sandy region. Now, these saline areas and sandy regions, you don't know what is going to happen, how much rain is going to be received. Now we have told furrow irrigated bed, broad bed and furrow system planting is. In furrows, rainwater will be retained. On the beds, the crops which are having sensitive to water, high water is kept on the beds. So in the event of heavy unknown rainfall situation, in furrow, water-loving crops like rice is planted. On raised bed, millet crops are planted. At this stage, the water in a mid stage of the crop, Nowadays, rice crop is taken, produced in the furrows because the excess water can be tolerated by the rice crop, or the millet crop or the drought tolerant crop, maybe sorghum, bajra, maize is put up on the raised bed. So it is even the flooded areas also, wherever flood can flood up to flood level, you can take up rice crop. Above the flood level, you take the less water, low water requiring crops like the millet crops. So wherever you are going the millet crops, you are changing the land configuration with broadbed and furrow. Nowadays, aerobic rice cultivation is coming, or SRI is coming. The furrows can be utilized for cultivating water tolerant short duration crops. And in between, you can eliminate some of these crops. Suppose you are having less water resources. On bed, you are having some millet crop. In furrow, you are having a rice crop. If the water, you are anticipating water is going to be a problem in the later season, you harvest the millet crops for the fodder purpose that can support livestock. The rice crop that is there in the furrow will be producing the food required by the farmer. You know that among the millet crops, the finger millet is transplanted. To some extent, that can tolerate waterlogging also. So that can be a choice in rice. In place of rice, you can put a finger millet crop in furrow, other millet. So these type of climate innovative practices have been evolved even for the sandy areas. Now, you know that the one practice system of rice intensification is there. That is based on 6 principles: single seed, young seedlings, single wide spacing, organic manure, cono weeding, and these are the 6 practices are followed in rice crop, where the yields, because of this is Madagascar, system of rice intensification has been developed by them, but there's some the church father that has been taken across the world, and they have found out the basic scientific principles under system of rice intensification. If your cono weeding is done, if you are taking up single seedling, young seedling of 8 days in rice, it will be having less transplanting shock. And if you are continuously moving the cono weeder, the roots gets damaged and the weeds gets incorporated, they will be adding organic matter, and the damaged roots, they absorb more nutrients. Young roots, they absorb more nutrients. So organic manure application, all these things, the SRI is a success even in India. This system has been extended to among the millet crops to the finger millet. In finger millet crop, especially in Mara, the average yields of finger millet is around 1.2 tons in the country level. But in system of finger millet integration, farmers up to 6 tons have realized. In Chhattisgarh, Jharkhand, in Orissa state, this system of finger millet integration is promoted. Even in Uttarakhand, the yields are twice as that of this one. Once here you are these type of practices can also be system of finger intensification can be adopted. Here you are transplanting, means you are reducing the crop duration. If you are putting the seed for germination and all that one, 15 days time is taken. If you are transplanting that one, 15 days time in the field is reduced, so that crop duration in main field is less, and whatever water is available, that is effectively captured by this. So system of crop intensification and transplanting is a mechanism by which you can. I have already spoken about crop insurance. Pradhan Mantri Fasal Bima Yojana, it is providing this one. We leave that one, but the other aspect is in dry land situation where you are having less water resources, the crop, because the water is less in the soil, the roots fail to take up the applied nutrients from the soil or the nutrients that are mineralized because of the decomposition. So under drought situation, the roots fail to support the nutrient uptake requirements of the crop. Under that situation, you have to go for the foliar nutrition. Nowadays, we are coming up with nano urea, nano zinc, nano copper. IFCO has come up with nano DAP also. though the effectiveness of these nano urea, DAP is debatable, scientists are not convinced. High input farmers like rice and wheat, even sugarcane, they don't see the benefits of foliar nutrition with nano urea and nano DAP because they are responsive to, they apply 200 kg of nitrogen for wheat crop and you spray 1% nano urea, the crop will not be giving sufficient yields. But in drylands where the crops, there is no water from the soil side, soil is deficient in water and the roots are not able to take up the nutrients and crop needs the miserably fertilizer is required at flowering stage for grain filling or to reach the reproductive stage or pollen viability is affected because boron is not there. So in such situation, you can go for the foliar nutrition of the, I don't say the go for the nano urea material. Farmers are practicing spray of urea, 2% urea or 1% DAP, even seed treatment chemicals like potassium, KH2PO4, potassium nitrate, even the anti-transparents like malic hydrazide. These type of chemicals, you have to use the chemicals through foliar application. Now the foliar application, the silly problem comes, you wanted to spray 1 hectare area, you need 2 people. One person requires, he has to bring the water. Maybe 500 liters of water per hectare is required to spray that one. He has to bring maybe 10, 20 parts of water, buckets of water from somewhere. Even 30 buckets of water you have to procure. So one labor is required for procuring the water and mixing the spray fluid. Other person is spraying 1 hectare. So nowadays labor price is up to 700 to 800 rupees. So to do a spray, you are costing maybe 2000 rupees. That is why foliar spray is deterred by high cost of spraying. Now what is the solution? Now the government of India is promoting drones. Namo Didi, Namo Drone Didi, all these. Government of India has given KVK, each KVK under ICR and SCIU, 1 drone to demonstrate. Even ICR institutes have been given 2 drones. You demonstrate the utility of drones in spraying the inputs, whether it is fertilizers, pesticides, or even drought coping chemicals. For that one, or even crop health monitoring, the women itself are, they have a target of 10,000 women farmers, self-help groups. They are being given drones, and they have been training on operating the drones. They are generating income to themselves, these self-help groups, on hiring basis. Each farmer takes these drones. And if you are spraying drones, you put the 10 liters of water in by the time you procure 1 more bucket of water, in 15 minutes, the crop 1 hectare is sprayed. Means
రేపు ఒకసారి వచ్చి ఆ మిగిలినవి షీట్స్ పట్టుకొని వస్తే అయిపోతారు.
The cost of spraying of the 2000 rupees with a 1 hectare area with 2 people has come down. Hello, please don't speak. Unmute yourself. So the cost of spraying with drones, they have enabled plant protection is become easier nowadays because you are not the farmer. It is what you can say, the farmer friendly. Farmer is from morning to evening, he is walking in the field with a knapsack sprayer and spraying the crops and eating and spoiling his health. Now, if you have come a drone, even if it is a drought or a excess water condition also, you can spray the means. This is the things. The other thing is you have to continuously monitor the crop health. For the nowadays, leaf color chart have come up in rice crop, wheat crop, sugarcane. The nitrogen parameter is based in Chennai. They have come up with leaf color charts even for cotton. And the IIMR is developing leaf color chart. And next season it is going to be with the farmers for sorghum, pearl millet, and finger millet crops. So the nutrient, before applying the nutrients, either by foliar or soil, you have to monitor the crop health with the leaf color chart or spag meter. Western countries are moving the application of fertilizers based on the sensor. If the crop sensor, the greenness is very good, the tractor will not apply the fertilizer to that particular plant. But the next crop, it is weak and greenness is less and more fertilizer is applied. Suppose based on the leaf color, the tractor, automatic tractor releases the nutrients, whether it even chemicals also. They monitor the weeds that are present on the ground with the sensor, and the herbicide is directly sprayed on post-emergency herbicide exactly on the weed. One drop is put and the weed dies. And the crop is differentiated and the weed is not sprayed on the crop. So these Western countries are moving in this direction. So we are not lagging behind, but we are slowly moving in this direction. But some of the crops like sugarcane, maize, here the crop loggers have come and the sensor-based fertilizers applications are being done. And this is the LCC chart and zero-till application systems that have come. Now you have to use the climate resilient varieties. So some of the varieties that are all crops, government, these ICR institutes have released the varieties that can cope up with either they are early in duration or they have high temperature tolerance or quick grain filling mechanism and low water requirement. Such type of varieties have been released even for rice crop, wheat, pulse and oilseed crops. And these are the two varieties that have been released. These are the climate resilient varieties, and this is M35-1 is drought tolerant, no doubt, but the improved versions for Pule Anuradha, for the shallow soils, verticals, and also Parpani Moti, such type of climate resilient varieties have come up, and these varieties seeds have to be made available to the farmers at opportunity side. The problem is that it is a drought season and you have kept up the sorghum crop that is a long duration traditional variety. But from the weather forecasting at last minute, Government of India came to know that the water supplies rainfall is going to be deficit, and long duration sorghum variety, which you are having maybe CSH 17, you have taken the seeds. But the rainfall is not suitable for cultivating that crop in that particular season. But immediately it is not possible to arrange a drought tolerant variety for the 1 million hectares sorghum cultivation. Is it possible? So we have to keep the reserve of the tolerant suitable varieties, not only the variety that is best promising under high input condition, but the crop varieties that are promising under vagaries of the climate change. So there should be mechanisms by which seed reserves of the drought tolerant cultivars is arranged by the Government of India or the state departments or Department of Agriculture for their district or the village or mandal level, so that the crop sowings are not affected. You say this year rainfall is not there. So entire maize cannot be cultivated or 50% area. So you cannot arrange alternate crop seeds for the 50% of the maize area or rice crop area that is farmers have left because there is no water for cultivating a crop. If you see the example of Krishna Delta, the reservoirs are filling late, and now the water is hardly 10% in South Indian reservoirs. And people have cultivated rice crop, anticipating the reservoir water will be released in the canals, they will grow. At flowering stage, the crop spoiled, there is no water, and even Telangana states, they have suffered a lot in Rabi season because there are problems with the water supplies from these reservoirs. Means you cannot arrange alternate crop seeds at short notice. There should be state department have to make their own alternate seed arrangements as a contingency measure, and that type of mechanisms has to come up in the coming years to overcome there are drought tolerant under drought situations, under low production, the poor people eating the millets, their nutrient content gets decreased. To overcome these things, biofortified millets have come up. Either zinc, iron enriched zinc. Now, pearl millet, all the varieties that to be released in India should have 30 or 40 ppm of zinc and 20 ppm of iron. Unless that much iron zinc content is there in that variety standard, they cannot be released. So similarly, such improved varieties with high zinc content, iron content, even vitamin A, have been released, and you have to use these type of cultivars, not only climate drought tolerant cultivars, but the high nutrient biofortified millets cultivars are available. They needs to be utilized. One thing that is lacking in millets is the mechanization. Manual tilling is done, manual sowing is done, manual weeding is done, manual spraying is done, manual harvest, manual threshing, manual eating. Everything is manual. But because of the manual operation, they become less profitable. Some of the operations, like harvesting or even herbicide application, intercultivation, sowing, it can be done. These are the seed drills that have pneumatic seed drills that have come up for maize crop. They are also useful for sowing the pearl millet and sorghum crops. If you are going to adopt these type of seed drills, the cost of production, so crop is established successfully because sowing distance, sowing depth is optimum. Manual, some people are putting at the top and some people at 5 centimeters. The top seeds on the top of the soil kept by the laborer, they will not germinate. But the seed that has been kept at deeper level, they may also fail to germinate. But such problems does not arise if you are going for the pneumatic seed drills like this one. So mechanization has to come up on a large scale. Now the last 1 or 2 slides we are looking at that seed drill. If you are going to use the water application system. When you are sowing them, now the tractor drawn implements have been modified. This is a 10,000 liter tanker mounted on the tractor, and they have been attached with the seed drill. The water from this water is released into the furrow. The seed is placed, and a small quantity of water is placed in this furrow. The crop is successfully germinated. This is a tank adoption. But the small changes, they have even plastic tanks have taken, and they put small quantities of water in the soil, and the crop is successfully germinated. Seed cum fetid drill attached with water tanker, they can be successfully used in the groundnut in Anantapur district of Andhra Pradesh. So that can be extended to millet cultivation. So where the soil moisture is not sufficient for germination of the crop, the water application, this is tractor drawn water application systems, seed cum fetid drill attached, where the crop establishment will be successfully done. And the whatever I have told that the sprinkler irrigation systems or effective drip irrigation systems could also come handy into this one. Chemicals can also be sprayed. I have told the last slide, we are coming to this one. Instead of sowing the crops in the seeds, if there is a delay in monsoon, you keep nursery raising at your home level. Suppose you are a millet cultivator, the crop sowing is delayed by 15 days. If you go for sowing of the crop, then the crop duration, sufficient moisture is not available at reproductive stage. On the contrary, if you are raising the seedlings for 1 month in your home, anticipating the rains, at the onset of rains, even at the delayed condition, if you go for transplanting of the finger millet crop, even pearl millet and the sorghum can be transplanted. So there, the crop duration is getting reduced by 1 month, one thing in the field duration. Other one, you can grow this crop without losing a season for the farmers, and they can receive the food production. So if you are adopting the improved practices with the climate, only improved practices are not going to make the farming successful in the coming years. You have to make the climate resilient practices as a part of the system. Then only improved practices coupled with agromet advisories, crop insurance schemes, the transplanting mechanism, whatnot, you see the moisture conservation, rainwater harvesting, and sprinkler irrigation of the based on this one, organic farming, all these practices together are going to make the crop production climate resilient. Millets, as I have told you, they are C4 plants. They can tolerate up to 50 degrees centigrade temperature. It doesn't mean that you grow them at 50 degrees centigrade. If sometimes temperature is reaching that 50 degrees centigrade, they can tolerate and give the yields. So all these practices will make the millet cultivation successful. I would like to close the presentation by saying this slide that humans are the only creatures on the earth. They will cut the trees first and they will make the paper from their pulp and write on the paper, don't cut the trees, save the trees. So we have to make ourselves climate resilient production systems. We have to avoid the greenhouse gas emitting systems and resort to low emission production systems. Water conserving is the crucial for the climate resilient production system. That is the key. Once you conserve the water, you can play with the water resources that have been saved. The saved water can be effectively utilized. So I try to put the things, I try to explain more than giving the slides to you. I take this opportunity to thank my team under the leadership of my director, Dr. Tara Sachavati, for giving me the opportunity to interact with you. And these principles we apply for all the crops. I told you in context of millets that can be extended to all other crops. And the other crops like rice, wheat, they are more amenable for conservation agriculture. But these millet crops are amenable for low input, organic farming, and also they are climate resilient systems, and they can be a food producers in event of a climate hazards. Thank you very much.